Hey everyone, welcome back to our programming journey. Today we are solving the LeetCode problem, which is single number problem in Python. So what exactly is the single number problem? Imagine you are given a list of integers where each number appears twice except for one. We have to find the number that only appears once. Let's consider an example. Suppose this is the list of integers with these values. 2 is occurring two times, so we have to return 1 in this case. Similarly, in example number 2, all the other values except 4 are occurring two times, so we have to return false 4. And similarly, in the example number 3, we have only one element, so we will return that element. Let's dive into the code. In the code, we are given a definition that is receiving two arguments. Our concern is only with this, that is receiving a list of integers, and it will return integer that specifies, that indicates the unique number in the list. Okay, so let's start coding. First, I will declare a set that I will use to store unique numbers. Unique number is equal to set. Okay. Next, I will declare a for loop that I will use to iterate over each number in the input list, which is in this case nums. Next, I will use a for loop for num in nums, which is the list that we are receiving. Next, I will check if the set already contains the current number num. If it does, I will remove that number from the set. If it does not contain that number, I will put that or add that number to the list, indicating that the number is a unique number. Let's check if num in unique number, then UNI unique number dot remove the number. If it does not have that number, simply in the else case, unique number dot add that number. Okay, I hope that is clear. At the last, we will return the unique number that is remaining in the set. For that purpose, I will return unique number dot pop. This line returns the single number found in the set. Since there is only one element left in the set, the pop function retrieves and remove that element. So that's it for this program. Let's run the program and see what happens. Okay, we are having an error. What is that? The name is unique, not unique numbers. Let's run it again. Our cases are accepted, so now we can finally submit the code. Okay, our solution is also accepted. So let's you can use XOR operator. Next, we will discuss another approach to solve the same problem by using XOR operator or exclusive OR operator. The exclusive OR operator provides a more elegant and efficient solution compared to using a hash set for the single number problem. Here is why. First of all, it takes a constant space. Using XOR, we can achieve a solution with constant extra space, which means we do not need to allocate additional memory proportion to the size of the input array. This is crucial for optimizing space complexity, especially for large arrays. And in our case, we do not want to occupy extra space. So next, linear runtime complexity. The XOR operator allows us to find the single number in linear time complexity, which is O of n, where n is the number of elements in the array. This makes it highly efficient, especially for large datasets. The XOR operator is a bitwise operator that compares two bits and returns 1 if they are different and 0 if they are same. If we consider an example, this is a 1 bit and this is 1 bit, the result will be 0 if we perform an XOR operation between them. If the bits are different, it returns 1, and the same in this case, the bits are different, so it will return 1. Here bits are same, so it will return 0. Next, for solving this problem, what is happening in the background? Okay, for that I will consider a table which will be decimal binary table. You know that decimals in binary changes from 0 to 7, means they are total of 8, which is also 2 raised to power 3 is equal to 8. So this is a decimal binary table. This is the representation of 0 in decimal with 3 zeros, and the decimal representation of 1 is this. So this is basic decimal binary table. Next, we want to perform XOR operation and see how the so let's see how we can find the number that has only occurred single or one time. Let's consider an example. If we take 2 to 1, what will be our approach? First, we will use a variable which will be of let's name it result. Okay, then we will XOR it with the input from this array. First of all, it will be performed by 1. Its result will be stored in our result variable. Next, we will also do the same, but here will be the next element, which is 2. Okay, which is 2. Let's see how it happens. If we consider an example over here, first we have 2. What is the decimal representation of 2? You can see the decimal representation of 2 is 0, 1, 0. So we will write 0, 1, 0. Next, in the result, first of all, there is nothing. I have initialized result variable with 0. So if we take the decimal representation of 0 is 000, you can see over here. This is the okay. So if we take 0, 0, 0, next we have to perform XOR operation. If we look back in the table, if the bits are same, it returns 0, and if the bits are different, it returns 1. So let's perform this XOR operation. If the bits are same, it returns 0. If the bits are different, it returns 1. So if the bits are same, it returns 0. So 0, 1, 0 is equal to this one 2. So in result variable, 2 will be stored. 2 will be stored in result variable. Okay. Next time, when we perform XOR operation between the result variable and our next element is also 2. Let's see how we can do that. We have a decimal representation of 2, 0, 1, 0, and the decimal representation of 2 is 0, 1, 0. So if the bits are same, what it returns 0. If the bits are same, it returns 0. Also, if the bits are same, it returns 0. So it results in the 0. Okay, next. Now 0 will be stored in the result variable. Next, so our last element is remaining 1. Let's do that also. Okay, if we perform XOR operation between 0 and 1, the decimal representation of 0 is 000, and the decimal representation of 1 is 001. Let's perform a XOR operation between them. 0, 0, 0 and 0, 0, 1. If the bits are different, it returns 1, and same, it will return 0. Let's see what is the it is equal to 1. So if we go back to in the list, and our task was to find the number that is only occurred once, so we have 1 remaining in the list. I hope that is clear. to you. Let's consider an example, which is this one. It is 0, it is 1. So in the result variable, what we have 0, and we want to perform an operation with this. Let's solve this. So it will be 0 0 0 0 0 1. If we perform a XOR operation between them, it will result in 0 0 1, which is again equal to 1. So 1 is the unique number in our result variable, and this will be stored. So this is the basic approach we will be using in our code. So let's go into the code section and write some code. Okay, so let's implement the XOR operator, which we have discussed. For easiness, I will hide this. Next, I will comment the previous code. First, I will declare a result variable that will be responsible for the number that only have appeared once. So for that, I will declare result and I will initialize it with 0 value. Next, I will declare a for loop to iterate over the values given by this num list. So that's for num in nums. Next, I will perform XOR operation between the result variable and the num variable that we have that is coming from this for loop. This for loop will return a single element in each iteration from the nums list. Okay. After performing the XOR operation between the num variable and the result variable, we will store the result in the result variable. Result is equal to result. In programming, the operator used for XOR operation is this one, which is also a symbol for raise to. Suppose 2 raised to power 3, that one. I guess that's the name for this operator. Next, I want to perform XOR operation between the num variable and the result variable. At last, I will return the variable result that contains the single number that have found after XORing the all numbers in the list. Return result. Okay, so let's try to run this code and see. So our cases are accepted. Now we can finally submit this code. And that's it for the video. We have discussed two approaches in this video. First, using hash set, and second by using the XOR operator. The approach for solving with the XOR operator is more preferable because we do not want to take an extra space. The hash set takes space complexity of n, and this approach using XOR will only take the time complexity of 1.